Good afternoon, I hope you're getting on well. This is the next topic and it's similarity. It's a fairly straightforward topic. I don't envisage too many problems, so we're going to get straight into it. So, similarity, we're going to look at similarity within lengths, areas and volumes. For the first video, we're just going to be looking at similarity within lengths. Okay, so what does it mean for shapes to be similar? Well, what it means, it says on your sheet hopefully, it means that they have the same angles. So all the angles remain unchanged between two shapes. All side lengths will have been multiplied by the same scale factor. Okay? So they have been enlarged. One shape is enlarged to get to the next shape. And then this final one's a bit confusing, but I'll demonstrate what it means. Corresponding sides will have the same ratio. We'll look at that during the rest of this video. Okay, so here are two similar shapes. I'm just going to label them. Okay, so here are some lengths. Here's another length. Now we can work, since we know that the shapes are similar, we can work out what the scale factor we use to multiply between these two sides. So to get from 3 to 7.5, I multiplied by 2.5. That's the scale factor there. And since we know they're similar, all sides have been multiplied by this same scale factor. So if I want to find out what the length of EF is, I just do 4 times by 2.5, and that will give me the answer. Okay? We'll look at this point next. Corresponding sides will have the same ratio. So corresponding. So AB corresponds with DE. So have a look at the side AB and you can see that's corresponding to DE. BC corresponds with EF and AC will correspond with DF. Okay, ratio. In this case, ratio, I don't really mean ratio with the colon notation. I mean ratio when you divide one side by the other side. So if I were to do AC divided by BC, so let's highlight that here. If I do AC divided by BC, that will be the same as if I were to do DF divided by EF, because these sides correspond. Okay? Now I know what AB is. I know that AB is 5, I know BC is 4, and this will be the same as DF, which I don't know at the moment, and that will be DF divided by 10 since EF is 10. Okay, so I've got this equation now. Since I know that these ratios are the same, I can write this as an equation with an equal sign, and then to find 10 I could simplify this as a decimal, so 1.25 is equal to DF divided by 10. That means that DF is equal to 12.5. This side is 12.5. This was using ratios between corresponding sides, but I could have got that answer just by doing 5 times by 2.5. That would have given me the same thing. Okay, excellent. We're going to look at a question now. This is a question which involves similar triangles, and we have some lengths that we've been given here. So ABC and ADE are similar. Okay, so we need to work out AD and CE. AD. Just maybe pause the video now, see if you can work out AD and CE yourself, and then come back to this. Okay, so AD. Well, let's look at what the scale factor between the two similar triangles is. So if we compare ABC to ADE, well, we know that it's been times by 4 because these two sides here are corresponding and we times 4 there. So the scale factor between all the corresponding sides will be times by 4. Okay. So we know that AB, to get to AD, since they're corresponding, I'm going to have to times both sides. I'm going to have to times the length AB by 4. So AB is 2.1, if I times that by 4, I'm going to get 8.4. So that means the length AD is 8.4. Okay, excellent. Let's go back a bit. Right, now we're looking for this side, CE. So maybe pause the video if you haven't worked out CE already and do it yourself. Okay, so CE. What do we know about CE? Well, we don't know much about CE yet, but what we could say is that to get from AE to AC, I might divide by 4. Okay. To get from AE to AC, I might divide by 4. Because we know the scale factor is times 4, so to go the other way, we divide by 4. 10 divided by 4 is 2.5. So that means that green length there is 2.5. AC is 2.5. Okay? Now this makes the question very easy. Once we know AC, we know that CE is just AE take away AC. So that means that CE is going to be 10 take away 2.5, which is 7.5. Okay? And that's it for this question. I'll stop this video and I'll make another video to talk about scale factors with areas and volumes. So if you could make sure that you watch the next video before Tuesday's lesson, that'd be great.